Okay, so today we will be performing a chi-square test on a genetic cross between the trait of flower colors between red, pink, and white. So a chi-square test is a test that would be used to see if numerical data are statistically different from your predictions. We use the chi-square test to accept or reject our null hypothesis. And we have an example of this right here. So the problem is, in a particular plant, the trait of a flower color appears to show an incomplete dominance because when a red flowered plant is crossed with a white flowered plant, pink flowered results. So two pink flowered plants were crossed and the following results were obtained. So you see that there are 64 red flowers, 112 pink flowers, and 53 white flowers. So what you do is you take that data and you see that the two pink flowers are crossed. So then you cross two pink flowers. So you use capital P, lowercase p, lowercase p. And then the capital P represents the red, and then the lowercase p represents the white. So then you cross that, you get 1/4 red, you get a half pink, because capital P and lowercase p give you pink flowers, and then lowercase give you white. So that's 1/4. So then what you do with that data is you multiply the total amount by whatever you get from here. So for the red flowers, you got 1/4. So we'd multiply 229 by 0.25, which is 1/4, and then you get 57.25. And then you do 229 times 0.50, and that would equal to 114.5, because the 50.50 represents the pink, which is 2/4. And then the same thing with the white, you would do 229 times 0.25, which equals 57.25, and that's how you would get your expected results for the chi-square test. And then what you do with that data is you have this formula. The O represents observed, the E represents expected. All you need to worry about is this right here. So you do 64 minus 57.25 squared, because you have the observed amount from the red flowers minus the expected amount of the red flowers, and then you're going to divide it by the expected amount, and you're going to do the same thing for the pink and the same thing for the white, and then you get this number right here when you do the calculation for the red, and you'll get this number right here for the pink, and you'll get this number right here for the white if you do all of your calculations correctly, and you will end up with 1.167 as your final answer. And so what you want to do is, why do you have that number? Like, what does that number represent? The number represents what you get from doing the chi-square test. And what you have to do is, the degrees of freedom is going to be 3 degrees of freedom. You're gonna subtract, because you have you get the number 3, but you have 1, 2, 3. You have 3 different flowers, different colors of flowers, and then that's what you get for the degrees of freedom. And then you'd subtract 3 minus 1, and then you would get 2 degrees of freedom, because every time you have a chart, let's just say that you had a chart with only 2 things. Let's just say, let me draw it a little better. Let's just say you had a chart and it was only red and pink. You would do 2 minus 1, and you would only get 1 degree of freedom. And the critical value you get is the value from the degrees of freedom, which you have right here from the chi-square table. So you have 2 degrees of freedom, which is right here, and then the critical value, which is 5.99, you have from right here, 5.99. So you always look at the top row when you're doing the chi-square test. And so what you want to do is, what does the 5.99 mean? It represents the p-value and the critical value. And for the 1.167, which was your final answer, you would have to see if the 1.167 is lower than your value. And it was. If the value is equal or higher to 5.99, then you would fail the test, because it means it's over and the prediction is wrong. So you would pass the test because the 1.167 is a lower number than the 5.99. And that is how you do a chi-square test on genetics. And that is all. Thank you.